Tech Revision with Mrs. Swanee Pooh. Hi Year 11, another video today on developments in new materials. So this video is going to focus on all of the modern materials that you see on the screen in front of you, and we're going to talk through each of these in a little bit more detail and some of the things that you just need to remember about them. So firstly, what actually is a modern materials? Normally they have been developed with a specific use in mind. So sometimes you can know what the use is going to be before it's made, and sometimes it can be due to new or improved manufacturing processes, which is a little bit like technology push really. So modern materials are basically developments in materials that are driven by new manufacturing processes, and quite often they have specific uses in mind when they are actually created. Right, onto the first one, which is graphene. So graphene is a really clever material. It is a super thin layer of graphite, exactly the same stuff that you have in your pencils, okay, so in your pencil leads. And this really is the kind of material that could open up huge new markets and replace existing technologies, because this material is incredibly light and strong, but one of its major benefits is that it can be an excellent conductor of heat and electricity. So it's got loads and loads of different things you could use it for, but one of the big things that potentially it could be used for is a very thin layer of graphene could be added to a flexible polymer screen, and because it conducts heat and electricity so well, you could make super thin flexible touch screens like the ones on the screen here. It's got lots and lots of other different types of applications in things like batteries, in LED lighting, in airplane components, all those different types of things. But massive advantage of it is super thin. So it can be super thin because it's just one literal layer of graphite kind of molecules, meaning it's very light, very strong, and an excellent conductor of heat and electricity. Right, the next material we're going to talk about is titanium, which is basically like aluminium's beefed up cousin that went to the gym, because titanium has loads of advantages. It is very low density, meaning for the amount that you use, it's very lightweight. That's kind of why it's used a lot in aerospace and things like that, and lots of applications where you want it to be relatively light. Things like implants, so things like hip joints, golf clubs, you want power but you want them to be quite light and not too heavy. So titanium, the first thing is it's quite lightweight, but for how light it is extremely strong. So it has a high strength to weight ratio. And it also has high corrosion resistance, so it's not going to rust, it's not going to deteriorate. That's why it's so useful for things like hip joints, which are obviously exposed to lots of different things when they're inside the human body, used for things like dental implants, and also used in aerospace for turbine blades, all different types of things. So titanium is a bit of a wonder metal. It's used in lots of different applications. It can be quite expensive to machine, but it's got extremely high strength to weight ratio, even better than aluminium. Right, the next material we're going to talk about is metal foam, which is really interesting, and it's as simple as it sounds really. It's just metal that has had air pushed into it, injected into it. So it's almost like, think about polystyrene, but if the little bits, or a sponge that you have in your bathroom, but imagine the outside is metal. Okay, so that gives a lot of advantages. It makes it extremely lightweight, but you still maintain a lot of the advantages and the properties of metal. So it's very lightweight, but under compression, So if this was squeezed together here, it would be very, very strong in that direction. So under compression, it is very, very strong. It's very stiff. So if you had a piece of metal foam, it's not going to bend. It's going to stay nice and straight. And it's very tough, so it can withstand impact. Okay, so it's got lots of different uses. Used in cars, car bodies, because of how lightweight it is. Often gets used in like crumple zone areas where you might be in a crash. It's used in armour, so like things like tank armour would have a sheet of metal foam, maybe in certain areas on the tank, because it's been proven to stop bullets and projectiles, better than having just a massive thick layer of steel, which would be very heavy. Metal foam is being seen as a really good alternative, and also it's been used in things like joints, so replacement metal joints. You get the stiffness and the toughness, but also again the advantage of it being very lightweight. So that is metal foam. Right, on to the next few. These are all kind of existing materials that have had some changes made to them to produce something very, very useful. So the first one is a bit of an old school piece of technology now, but it's called LCD. So on your calculator, that is an LCD display, a liquid crystal display. And basically the way it's used is liquid crystals that are used in this display are made up of different types of chemicals. Now, when a current is applied to the screen, the shape of those crystals changes, which creates a display on the screen. So you could basically apply a current and you would get a display to come up on the screen a little bit like this one. Now, you don't need to know all the science behind that. You just need to understand that's kind of the way that it works, but also the advantage of this is that it's very thin, it's very lightweight, and it's very, very energy efficient. So LCD screens, quite often you see them on low-cost electronics because they are so energy efficient. You only need a small current or a small amount of power to go through the screen to get the display to show. Now, nowadays, you get color HD LCD displays, but they kind of started off in things like calculators, children's toys, and that's how those work. So that's a liquid crystal display. Right, the last couple we're going to talk about, this one is called this is coated metals. Now, this isn't very complex, and we may have covered this before in surface finishes, but this is basically coatings that are added to metals to enhance their properties. So things like steel, which would usually rust if it was left outside, has zinc added to it, and this is called galvanizing. So it creates a chemical bond which protects the steel from corrosion. So that is an example of a coated metal. Another example of a coated metal, and I'm sure that you've done this in science with electroplating, where you have the cathode and the anode. Electroplating is used quite commonly. An example of it is nickel is often used to cover or to plate steel, and that is used in things like car parts. But also you can electroplate, you can have gold plating, tin plating is used on tin cans. So those are examples of coated metals, quite a simple concept. Now, the last couple are quite interesting. Nanomaterials sounds a lot complicated than they are, but it just means small, tiny materials. So nanomaterials are made of tiny particles, and a really good example are these here, carbon nanotubes. You may have heard of them before. Any of you sort of interested in engineering or anything like that may have heard of these, but they are basically almost like microscopic structures made from carbon, which we know from graphene is very strong, conducts heat and electricity really, really well, and very, very lightweight, but a very high strength to weight ratio. So these carbon nanotubes can almost be stacked kind of together. If you imagine loads of these tubes all next to each other, that's going to give a lot of strength in compression and in all sorts of different directions. And they can be added to lots of different types of equipment, aerospace, sports equipment, bulletproof vests even. They can be used in electronics to conduct electricity. But the big advantage of these carbon nanotubes is they add a lot of strength without adding too much additional weight. So a good example of a nanomaterial is a carbon nanotube. Some more examples of nanomaterials, and I quite like these examples, is self-cleaning and antibacterial fabrics. So these are fabrics that actually have tiny little particles in the structure of the fabric that carry out different jobs. So for example, you could have some self-cleaning socks. Well, they're not really cleaning, but they remove odors. So they would have some kind of chemical within the structure of the fabric that would repel the odors, so they wouldn't smell. And that, yes, that is the best picture of a smelly sock I could find. So they would get rid of the kind of odors that build up in things like socks and all sorts of things like that. So that's a coating that could be put onto fabric. And this one's really good, this antibacterial fabrics. They have silver particles in the actual fabric of in the actual structure of the fabric. And imagine the uses in places like hospitals, and that's where these things kind of tend to use, because silver actually is naturally antibacterial. So quite often things that are in hospitals have a silver coating or have some kind of silver kind of used in it because it is antibacterial. So it could be used on things like scrubs, it could be used on face masks, but these antibacterial fabrics use silver within them, and the advantage is that they can't be washed away. It's in the structure of the fabric rather than just being a coat, kind of a spray or something that you add to it. Okay, so that is a really quick whistle-stop tour of modern materials. Those are all the ones that you just need to have a bit of an awareness of, but also learning a couple of those will be a really good idea just in case you're asked to give any examples. Okay, see you on the next video.